Hello everyone, we are Team DX, and I'm Sun Chenglu. We come from Hangzhou and Shanghai AI Lab, Interactive Entertainment Business Group, NetEase. Next, let me briefly introduce the principle of our bot in the finals. First, let's introduce the main difficulties of the Chinese standard Mahjong AI we thought. The first one is its high win fans, which makes it completely different from Japanese Mahjong or other Mahjong type. The second one is its large number of fan types, which lead to a wins of Chinese standard Mahjong strategies. Thirdly, it also has large amount of unknown information, huge state space, and sparse rewards. Finally, the relevant research on its AI is real. Without any experience, we mainly applied 3 ways to explore the AI. The first one is reinforcement learning, the second one is behavior tree, and the third one is search algorithm. This is the input form, output form, and score provided by BotZone. This score seems to encourage simultaneous offense and defense, but in the actual testing, we found that for the Chinese standard Mahjong, offense is more important than the defense. Here, we adopted the way of Microsoft Asia Research for input processing. The play information was turned into a two-dimensional input form as a network input. At the same time, it was organized into one-dimensional data, which is used to the behavior trees and search algorithms. Then, let's introduce the RL method. We use the two modes to handle the entire Mahjong operations: discard mode and judge mode. The discard mode was used to determine which card to play at the play round. The input is 52 multiplied by 34 two-dimensional tensor, and the output is the probability of all 34 cards. The judge mode is used to determine whether Chou, Peng, and Kang is needed. The input is the two-dimensional input of 64 by 34, and the output is 0 or 1. The algorithm we use is the classical PPO. The mode is trained from scratch, and the reward is the fans divide it at the last round of winner, which is sparse. The interaction logic was close to the Impala, but it used PPO as the training algorithm. The training process requires 8 GPUs and 256 CPU cores, and the network size is about 14 layer CNNs and 3 dense layers. The Mahjong environment was made by ourselves. A big characteristic of the Chinese standard Mahjong is its rich strategies. Therefore, when we use the PPO to train only one mode, the effect is not good. The trained mode can only adapt to a certain type of strategy, such as 3 Chous or all types. We believe that this is because the PPO algorithms requires that the KL divergence of the new and old strategies be close, and the network parameters are not enough. Therefore, we tried to divide the Mahjong strategies into several categories. Spiral fans, which contains greater owners and knitted tails, 7 pairs, and the 13 offense. The 3 Chous, which contain mixed shift Chous, pure shift Chous, pure straight, mixed straight, and mixed triple Chou. The all types, which only contains all types. The flush, which contain half flush and pure flush. The all Pengs, which only contains the all Pengs. the outside hand, which only contains the outside hand, and the others, which contain all fans. After testing and analyzing, we applied the RL method to learn the switches, all types, all puns, and other categories. After training, for each agent in each sub-mode, it can achieve a winning rate of close to 24% in self-play. At the beginning, we applied the behavior tree to handle the special fence, outside hand, and servo mode control part, which are not performed well by the RL mode. With the understanding of the Chinese standard mahjong, we found that many other fan types can also be easily implemented with a behavior tree that has stable logic and do not need to spend resource to train. So we finally use the behavior tree to realize the three choices, all puns, and all types. But this method has a disadvantage, that is, when the hand tails are not good and not close to most of the fan patterns processed by all submodes. The whole mode does not know how to play, so we decided to use a search algorithm to solve this problem. The search algorithm we use mainly based on the official fan calculator and shunting calculator. First, we establish a search tree and try to change each hand tail for obtaining each child nodes. Then, we repeat this process until find some leaf nodes whose hand tails have more than 8 fans. Obviously, it's difficult to perform a wide and deep search within 6 seconds for Python language, so we conducted a lot of pruning. Finally, by sacrificing the wings, we can search for a depth of 3 or 4 layers. At the beginning, we planned to get the boat with all trained modes of reinforcement learning. With continuous iteration, the components of the boat are changing. When only using the RL mode, the rank score of the boat can only achieve about 1100. Then we added the sub-mode control part and special fans obtained by the behavior tree, and the rank score could reach about 1150. Then we continued to use the behavior tree to correct the RL mode. The boat can around be 1250. Now, we also added the search algorithm, but there are not enough games to test its stable effect. This is the method distribution map of our final boat. Finally, we will introduce the advantage and disadvantage of our boat. The advantage of our boat are 1. The running speed is fast, and there will be no decision timeout. 2. Low coupling is easy to modify and convenient to add new strategies. And the boat's behavior is easy to control. And the disadvantage is 1. Employed lots of behavior trees, which cannot be used in other scenarios. And 2. The servo-mode control part applied some hyperparameters, which have great effects on the boat. Finally, if you have any questions, please feel free to contact my individual email. And it's my pleasure to give the presentation. Thank you all.